So good morning, good afternoon, and good evening, guys, based on the time zones you all are coming from. So guys, before we start with the session, can you all please give me a quick confirmation if you all can see my screen and hear me loud and clear as well? You can use the questions tab to give me a quick confirmation, guys, if you all can see my screen and hear me loud and clear as well. So guys, can you all please give me a quick information if you all can see my screen and hear me loud and clear as well? Perfect. Thank you for confirming, Rupa, Naresh, Ravi, Manmohan. Wonderful. Thank you so much for the confirmation, guys. All right. So, and before we start with the session, guys, there's a simple single rule that we have to follow in the entire session to have a smooth delivery. In case you have any question, any kind of question, guys, please feel free to ask those questions and queries in the chat window. So let's suppose when we are discussing on any topic and you have any confusion on that topic, please feel free to ask as many questions as you want, right? And so that once I have the visibility on your questions, I can go ahead and ask and give you a proper clarification on the same. All right. Because the main motive of this entire session is to make it as interactive as possible, right? So in case you have any questions, please feel free to ask those, and I can make sure that those questions are answered one by one spontaneously. All right. And sometimes it may happen, guys, since we have a good number of participants joining in, so it may happen that sometimes some of your queries may be buried down in the pile of questions that we will be getting, right? So if that happens, don't feel disheartened and continue to post your questions again and again so that your questions have a good visibility and I can try to answer it. All right. So now let's get started. So before we start, guys, so now those who are joining from YouTube, so you can join our meetup, right? So meetup is a platform on which we have multiple members who have already joined, right? So in Meetup, we conduct more than 100 plus webinars in every month, where these webinars range from different ranges on different topics, including cloud computing, DevOps, mobile and web applications development, right? So there are more than 100 plus webinars, and you can all join this to stay updated on the current trends on these technologies, how the companies are using this, and what exactly we need to get started into our career into these different domains, right? And these are completely free of cost, so we don't have to pay anything for attending these webinars, right? So this will be a good tool to increase your knowledge, guys. So let me share this link with everyone so that we can all go through this and join it. Just a moment. All right. So our team here will be sharing with all the participants who are joining from YouTube. So this is a great tool to stay updated on the current trends. And as you can see, there are more than 100 plus webinars that we conduct on a monthly basis. All right. All right, so now let's get started. So now let's assume our journey on Kubernetes, for which we have joined today. All right. So the main motive of today's session here is everyone will be focusing on Kubernetes, why exactly we need Kubernetes, what exactly it is, and the entire infrastructure for Kubernetes. We'll be having a good understanding on that. Then we'll see how Kubernetes helps companies in making sure the entire application is well integrated. And these are all up and running in all three environments, be it testing environment, production environment, or the development or the staging environment, right? And what are different use cases of Kubernetes, how Kubernetes has helped multiple companies, especially we will be looking at the use case of Pokemon Go, right? And then towards the end, we'll be having a good understanding on Kubernetes deployment. That means how we can deploy Kubernetes into our system. And here we'll be looking at the cloud platform, mainly for the cloud platform. Why? Because again, we know that VM is not accessible by everyone, right? So for those who are for those who don't have the access to any VM, or those who are limited by the hardware, we can all go ahead and use the cloud platform to deploy one VM for us, right? And that will be focusing to as we continue further in our journey. All right. All right. So now let's get started, everyone. So now containers, now we must be aware of containers, right? So containers are what? Containers are basically the self-dependent, or we can say self-dependent package that we can use to deploy our applications, right? Now, when we talk about when we talk about our containers and what exactly we mean by containers, for example, let's say we have an application, right? Let's suppose here we have an application deployed now in V now. We also take the help of VM for testing or for running any particular applications, right? But VM are resource intensive. That means they have the entire OS system on each and every VM takes up majority of the resources, right? So that the deployment of multiple VMs cannot be done in a system which is limited by the physical storage, right? Or physical capacity. But in terms of containers, if we are using containers in as an example here, then what we can do here when we are using containers, here containers simply contain all the predefined packages. For example, all the bins, all the libraries that is required for making sure that the entire application has its own environment for the current functionality, then these all things are packaged inside the container itself. So that makes the entire application self-dependent, right? So all the bins, all the classes, all the libraries are all attached inside this containers, right? With the image of the companies of the application that can be executed as a part of the containers, right? So containers are self-reliable, are self-sufficient in running and testing the entire modules, right? And that's why we use containers instead of VM as a part of a deployment, especially in our DevOps strategy, here. All right. And containers can be Linux, and again we have Linux containers, and then we have Docker containers as well, right? And containers, as we discussed, these are reliable, these are efficient and lightweight as well, which can be scaled up exactly as per the requirement, right? But the main drawback that we face in containers, it is scalable, but it is not easily scalable. For example, let's say for some reason we want to increase the if we are seeing too much traffic coming in, right? Then we cannot increase the containers, be it horizontal scaling, we cannot go ahead with vertical scaling as well, right? So scaling is a big issue in containers, and that is observed by almost every developer out there globally, right? And for solving this issue, we do have a concept called Kubernetes. We do have a concept called Kubernetes here, right? So Kubernetes is basically, and again, as you can see, now, first of all, what exactly the problem is? Let's discuss that. So containers cannot communicate with each other when we have a cluster of containers, right? When we have a spatial cluster of containers, then that makes it simply less efficient, because again the communication here is a big gap, correct? Containers cannot be deployed appropriately in the same structure or cluster mode that they are intended for, right? And each and every containers has to be managed carefully, and again that requires a lot of time, both lot of time and resources, because that has to be done manually, right? And here we can distribute the entire traffic exactly as per the requirement. Again, that is not easily deployable using the conventional methods, right? And auto scaling, when we talk about auto scaling, then what do we mean by auto scaling? Anyone? Any idea, guys? When we talk about the term as auto scaling, any idea what exactly we mean by auto scaling here? Anyone? Please don't hesitate from getting it right or wrong, guys. As long as we all are interacting, that's the main motive of this entire session being fulfilled, right? Ravi, so okay, Raghvendra, based on traffic, scaling up and down, scaling the system based on performance, equal, monitoring the task, Kamali. Naresh, increasing the instances or making the instances, yes. Surya, scaling servers according to the traffic, absolutely. Scaria, based on the resource shortage, scaling up, exactly, right? So based on the requirement, we can scale up, and we can scale down the resources exactly as per the requirement, right? Right, Feroz, ready, routing the traffic. Eben automatically scales up the containers. Alexander automatically adds more resources when we need it. Exactly. Alexander, Girish, absolutely. So here what we are doing, we are simply increasing the capacity of the containers, right? And now if we talk about scaling, then there are basically two types of scaling. Let's look into that. When we talk about scaling, basically there are two types of scaling that we can discuss. Let's discuss these two scalings so that we can have a better clarity on what exactly scaling is and how scaling help us, right? For example, let's say here we have two scaling. Now, when we talk about scaling, we have two types of scaling available. We have horizontal scale. Now, suppose if we are talking about scaling, right? So scaling is basically of two types. Here we have vertical scaling, and then we have horizontal scaling. We have horizontal scaling, right? Now, in first of all, in horizontal scaling, what happens? For example, let's suppose here we have now in horizontal scaling, here we have deployed three servers, right? For example, here we have deployed three EC2 instances. Here we have one, then we have two, and then we have three, right? Suppose we saw a sudden surge in traffic, right? And each and every of these instances are having, so for example, suppose they all have 1 GB of RAM and 1 core of CPU, all of these three instances. Now, suppose if we see a sudden surge in traffic, instead of increasing the capacity of these resources individually, what we can do, what we did, we simply added one more resources. We simply added suppose one or two more instances as per the requirement, right? We did that, right? So what we have done, instead of increasing the capacity of these servers, we increase the number of resources here. All right. And whereas if we talk about vertical scaling, suppose in vertical scaling, same scenario, if we again have three instances or three servers being deployed, right? Now, and again, suppose each and every instance again is having 1 core of CPU, 1 GB of RAM. Now, instead of increasing the number of servers here, what we did, we simply increase the capacity of each and every server. Suppose from 1 GB, we increase it to now 4 GB of RAM and 4 cores of CPU, right? So this is a part of vertical scaling. So vertical scaling is when we increase the capacity of the servers, and horizontal scaling is when we increase the number of servers or number of resources here. All right. So are we all clear on the concept of scaling, guys? Please give me a quick confirmation, everyone. Are we all clear on the concept of scaling here? Rupa, Neha, Kamali, Surya. Perfect. Thank you for the confirmation, guys. Wonderful. Thank you for confirmation. Okay, Raghvendra, so is there a possibility where we use both scalings? Raghvendra, we can use that. Now here we can define conditions. We can define conditions. That means suppose, and that's why we have load balancers, right? That's why we have something as load balancers. If we want, we can increase. If we want, we can define the logic, how we want to increase or how we want to decrease it. Is it clear, Raghvendra? Perfect. Thank you for confirming. Just a moment. So that's exactly what we mean by the scaling part here, right? So we can increase or decrease the resources exactly as per our requirement. Now, let's understand a container management tool, right? So again, to remove all the drawbacks that we had seen here, we can use a container management tool through which we can remove all the drawbacks that we were facing in setting up the containers, right? And Kubernetes is one of the tools. Now, Kubernetes is an example for Docker, or we can say container orchestration tool, right? So Kubernetes is an example for container orchestration. That means here it is simply a container management tool which can help us in its deployment, in scaling up and down, and taking care of the entire load balancing as a part of our entire tool here. All right. Okay, I have a query from someone. Okay, Seven. So may I know how we can increase? Like in which context are we talking about, Seven? Please give me a quick information. So kindly elaborate so that I can answer it correctly.
Several people have that said people have services like a model scaling, right? Model scaling is available on their platform, cloud platform, AWS, Ansible, right? So through that, we can take care of model scaling and stuff, right? So guys, can you all please give me a quick information if you all can hear me loud and clear? As just a moment, guys. Guys, can you all please give me a quick information if you all can see my screen and hear me loud and clear now?
So guys, can you all please give me a quick information if you all can hear me loud and clear now, as we have changed the network here? Sarup, Giri, Ronnie, Shravan, Rupa, Ajay. Wonderful. Thank you so much for the confirmation, guys. And thank you for your patience and for staying put. Shubham, Sai, Girish, Swati, Ashish, Shashank. Perfect. Thank you for confirming, everyone. So now let's proceed. All right, so that's why we have the container management tool offered by Kubernetes. So Kubernetes simply help us in making sure that we are deploying, we are descaling, we are scaling up and scaling down all the resources exactly as per the requirement, right? And Kubernetes now, Kubernetes is written on Golang, right? And again, it has a huge community because it was the first developed by Google, and then it was later donated to CNCF, right? And here we can have a group of like no. Now here we have can group of n number of containers. So there is no limitation in the number of containers that we can add on top of Kubernetes, right? And Kubernetes, again, they can be managed simultaneously and parallelly in a given operations, right? Which can be scaled up, which can be scaled down exactly as per our requirement. All right, and that's why we have Kubernetes in place, right? So these are the main features offered by Kubernetes. Here we have automatic bin packing. So again, the entire bin, all the bin and libraries that is required for the containers, these are automatically packed by using Kubernetes, right? The service discovery and load balancing that we had discussed just now, like we have vertical load balancing and then we have horizontal load balancing, right? That means if we want to add more containers, then we can do that easily using Kubernetes, right? And then we have storage orchestration. That means if we want to take the help of multiple storages, if we want to take multiple snapshots and use it every now and then we can do that easily using storage orchestration as a feature offered by Kubernetes, right? It is self-healing. Now, when we talk about self-healing, we simply mean suppose if there are some errors, and suppose one node, in the entire cluster, some nodes are not available or not reachable, then that can be shifted to something else, right? That can be self-corrected. That is a part of self-healing, right? Here we can execute the entire cluster. For example, let's suppose here we have n number of containers into our entire cluster, right? Then we can go ahead and perform the entire batch. We can also change the setting. We can configure it exactly as with the batch as well, right? And then it is well supported by Chef, by Ansible, so that we can also take care of the configuration management system as a part of Kubernetes. All right. And then we have horizontal scaling. So now here we can or take care of the horizontal scaling. That means here, if we want, we can add more number of servers exactly as per a requirement. We can do that. We can do that. All right. And then we have automatic rollbacks and rollouts. So that if suppose if one now suppose let's say we have 5 instances or 5 containers being deployed here, right? Suppose one container has again failed, right? Then this entire container can be rolled back to make sure that this does not have any effect in the other containers, right? And suppose if we have updated one container and again that container has failed, then here we can roll back to the previous version of the container as well to make sure we have an entire smoother functioning for the entire cluster of the container that we are working on. All right. So these are different features available as a part of Kubernetes. Okay, Raghavan, so can you explain about orchestration? Raghavan, sure, Raghavan. So orchestration is simply making sure of the entire deployment. That when we are deploying multiple containers, these are all done, these deployment can be done parallelly, right? The entire configuration can be taken care of by the platform itself, right? And whenever we want to add some more resources, if you want to scale it up, if you want to scale it down, then these all things can be done as a part of orchestration services, right? So orchestration is simply, in simple layman terms, it's simply deploying of multiple containers at once. All right. Is it clear, Ravindra? Please give me a quick information. Perfect. Thank you for confirming, everyone. Swati, Girish, Eben. Perfect. Thank you for confirming, guys. Now let's move ahead. Okay, now there are many myths in the market, in the mindset of people, especially those who are beginning with Kubernetes, about its own entire logic, right? Now let's go ahead and remove those myths, right? Okay, Vida, so can containers be of different configurations in a batch? Yes, Vida, we can do that. And that's and again for taking care now, and that's why for taking the configuration part, we can integrate it with multiple integration like configuration management tool that we have, Ansible and Stack and Puppet. All right, we can take care of the configuration management setup for doing that. Okay, Ramesh, so what is the difference between Kubernetes and orchestration? Ramesh, Kubernetes is an orchestration service. Kubernetes itself is an orchestration service here, right? So we cannot differentiate between Kubernetes and orchestration. Is it clear now? Perfect. Thank you for confirmation, Ramesh. Now, Kubernetes, now, first of all, let's see what Kubernetes are not. So Kubernetes cannot be compared with Docker because Kubernetes facilitates the deployment of multiple Dockers, right? Docker container. Kubernetes cannot be used for containerization of the applications because containerization is not done using Kubernetes. Containerization is done using Docker, right? And applications with simple architecture is of no use for Kubernetes, right? Because Kubernetes take care of deployment for complex applications having a big requirement, right? Having a big requirement here. Okay, Sai, so what is the difference between Docker and Kubernetes? Sai, we use Kubernetes for deployment of multiple Docker containers. So there's no difference, but again, here we can say Kubernetes, we use Kubernetes for deploying multiple Docker containers and taking care of its entire management. Is it clear now, Sai? Coming from YouTube, please give me a quick information. And I think this solves your query as well, Ravi. Is it clear now? Perfect. Thank you for confirming. So if we had to understand Docker here, so now Docker, we contain multiple, now in Docker, we create multiple images. For example, now let's have a quick understanding of what exactly Docker is. Let's go into a Picasso mode, just a moment. Now, whenever we have whenever we have done with building the file here, what we can do now, this build file, suppose this is entirely a Java application, right? Now, Java requires multiple libraries and extension for it to be deployed, correct? Now, once we are done with the entire application integration here, what we can do here we can create one Docker file which will define what exactly is the dependency of this particular file here, correct? And what we can do here first in Docker, we have three components here, right? So in container, what we do here, we have a Docker file which is used. Now here we can have an image, a simple Docker image of the application that we are trying to test. And we also have all the libraries and bins that is required for this image to work, right? So all the libraries and that is required for this image to work here, right? And this itself here, it's called as container, is it called as a container here, as a container, right? So if we are trying to test any application, then what we can do here is we can create an image of the application. We can create an image of the application that needs to be tested, right? and then we can deploy that image into the container with all the libraries that we have defined as a Docker file, right? So Docker file is basically used for creating the image here for the application, right? And this image can then be deployed inside the container, and the container contains the image of the application that needs to be tested along with all the dependencies on it, right? So that this can be we can say this can be a completely self-sustaining container that has all the packages that is required for the application to run smoothly without facing any kind of issues, right? And that exactly is the concept of container here. So are we clear on the concept of containers? Please give me a quick confirmation, guys. Are we all clear on the concept of containers here? Ramesh, Neha, Shravan, Naresh, Rupa, Venkat, Sai. Perfect. Thank you for the confirmation, guys. And if we talk about the orchestration tool here as Kubernetes, let's erase this up. Now, suppose, let's say we have 5 different containers that needs to be deployed here, right? We have the requirement of deploying, suppose 5 or 10 different containers, right? 10 different containers here, right? Then managing each and every container that they are all are functional fine or not, suppose if they are not running into any kind of issues, right? So this entire deployment of multiple containers here, multiple Docker containers, these are taken care by an orchestration tool here, right? And we can say Kubernetes is a part of orchestration tool, which takes care of the deployment of multiple containers in a single go. And this is done using Kubernetes. This is done using Kubernetes here, right? So the entire configuration of all the containers being deployed here, the configuration, their management, their load balancing. Now, when we say load balancing, suppose here we have one container here, right? And the load to this container is too much, then we can distribute the traffic from this container into 2 sub containers. We can do that into 2 other containers. We can do that, right? So all of these things are taken care by the orchestration tool, right? And Kubernetes is one of the most popular orchestration tool here, right? And Docker is the most popular tool for the container service, whereas for the orchestration purpose, we have Kubernetes. Docker also has its own orchestration tool called as Docker Swarm, right? But Swarm has multiple limitations, and Swarm is not that popular as compared to Kubernetes, right? And that's why we have Kubernetes as a famous orchestration tool. So are we all clear on this concept? Please give me a quick information, everyone. Are we all clear on the concept of orchestration tool? Ramesh, Rupa. Okay, Shravan, so can we deploy multiple Docker containers? Yes, Shravan, we can do that. Edureka, guess so Docker composed of Swarm as well. So why Kubernetes? Because Swarm has multiple limitations, right? So and that's exactly what we try to resolve once we are working with Kubernetes. Okay, Balaram, so can you please repeat the connection between Ansible and Docker? All right. So Ansible is a configuration management tool. For example, let's say when we are deploying any particular application to any server, right? For example, let's say when we are deploying any application to the server, right? So what should be the configuration of that server? Suppose what kind of services that needs to be present, right? Suppose let's say we are taking care of the Apache, right? Or suppose the entire configuration, that means how many nodes should be there, what should be the current version, right? So these are the current version, how many nodes should be there. So these all are defined using a configuration management tool, right? So we can say in configuration management tool, like we have Ansible, we have Chef, we have Puppet, right? So if you're talking about the configuration management tool, this file contains all the configuration that needs to be done on the server, like a template file, right? And once we are using this configuration management tool, the entire application can be configured accordingly, so that suppose if an application wants, so suppose if we are working on an application that needs a specific version of Apache being deployed on the server, right? So suppose there are some different versions deployed on the server, that will create an issue, right? So using configuration management, we can define which version we are looking for. And now configuration management template will make sure that this particular configuration is met in the server for a smooth deployment of the application. All right. And that's why we have multiple tools available for configuration management. We have Ansible, we have Chef, we have Puppet. So is it clear now? Balaram, please give me a quick information. Perfect. Thank you for confirmation, everyone. All right, so now let's proceed. Let's erase this. Let's remove our kindergarten drawing here. Let's erase this. And now let's get right back. Okay, Raghavendra, so suppose I have an Angular application which is consuming .NET Core API. This application is using SQL Server as backend. How do we process these multi-tier applications using Docker? As part of hosting, we need to have application pools, sites, and created manually, which I don't think can be automated using containers. And that's why we have configuration management tool, Raghavendra, right? So containers basically focus just on the application, not on the configuration of any other dependencies. For example, let's suppose here we want a live server, right? So what should be the configuration of that server? That can be taken up by the configuration management tool. Like we have Ansible, we have Chef, we have Puppet, right? And when we are combining these, then the entire configuration here can be met that we can on, and then we can start deploying the application on. So is it clear, Raghavendra? Please give me a quick confirmation. Yes, Balaram, we can use Ansible with Kubernetes. Kubernetes uses Ansible for this purpose. Is it clear now? Perfect. Thank you for confirming. Now let's proceed. Now, Kubernetes is actually the best solution for scaling with the containers because it's the industry leader in the market. It is backed by huge communities. So that's why we can find multiple plugins and support support two different applications out there, right? And here it can be used as a container orchestration tool that we had discussed. Again, it is more reliable and robust as compared to other platforms, here, right? And now this was also one of the question available. Like if we do have the Docker Swarm, then why exactly we need Kubernetes for? If you do have this Docker Swarm, then why exactly we need Kubernetes for, right? So now if we make a comparison between Kubernetes and Docker Swarm, then installation for Kubernetes is a bit complicated. Now that is agreed, right? That we do agree on. Kubernetes is a bit complicated, especially for those new beginners, those who are not good with the coding part. Again, the installation can be a bit of a tiring process because it is complicated, right? Whereas Docker Swarm can be deployed within few minutes, right? Within a couple of minutes, we can have the Docker Swarm up and running, right? But again, since it is complicated, obviously it is also rewarding as well, right? Because now Kubernetes has a GUI. Kubernetes has a dashboard through which we can operate, whereas Docker Swarm is not having any kind of dashboard. Here we simply have to work with the command line interface, right? Whereas in terms of scalability, here we can, now the scaling up is slow as compared to Swarm, because if we want to scale down, then that is quicker. But again, in terms of scaling up, that is slow as compared to Swarm, right? But again, here it can guarantee a stronger cluster rate as compared to Docker Swarm, whereas scaling up is faster than Kubernetes, but here the cluster strength is not as robust as compared to Kubernetes, right? And K8 is simply the abbreviation that we use for Kubernetes. So when we are using K8, again, it is well known in the developer community. That means Kubernetes, right? And then in terms of load balancing, if you want to distribute the traffic, then again, it requires a manual service configuration. That means we have to configure it first, and then only we can start using load balancings, right? Whereas in Docker Swarm, these are pre-built, right? So again, we have in load balancing technique that is already available as a part of Docker Swarm. And in terms of updates and rollbacks, here we can schedule the entire rollback exactly as per the requirement, whereas progressive updates and services are monitored through update. That means, for example, let's say we are continuously making changes in the versions. We have V1, V1, V2, V3, V4, V5, right? So all of these continuous versions here can are saved automatically as a part of Docker Swarm. And in terms of data volume, here we can have multiple things shared with the same pod, whereas it can be shared with any other container, right? So in Kubernetes, we can share the data volume with the container in the same pod, in the same environment, right? Whereas in Docker, if you want, we can also share this with multiple other containers. We can do that, right? And logging and monitoring is again for this purpose we have tools. And again, here we have third-party logging tools because there is no physical dashboard available for Docker Swarm as compared to Kubernetes. All right. So are we all clear on the concept, on the main difference between Kubernetes and Docker Swarm? Please give me a quick confirmation, guys. So please give me a quick confirmation, guys. Are we all clear on this part? Raghavendra, Ramesh, Thomas, Kamali, Naresh. Ramesh, so Docker Swarm has more benefits as compared with Kubernetes. So Docker Swarm is basically used for small scale applications here, Ramesh, and Docker Swarm does not have a GUI, a graphical dashboard, right? And again, here, then that's why here we can use multiple graphical dashboard, and then we can use we use Kubernetes especially for big applications as compared to Docker Swarm. That's the advantage. Is it clear, Ramesh? Please give me a quick confirmation. Perfect. Thank you for confirming. So Veera, so with these references, it's still worth of spending time for Kubernetes. Yes, Veera, because Kubernetes are basically used for big applications. And having the complete web dashboard for visualizing the entire performance of the containers. And that makes it easier for any particular person who is in charge of managing containers to wait for the entire report to be generated and take actions on these parts one by one. Wonderful. Thank you for confirmation, Veera. Perfect. Thank you for confirming. So Raghavin, so I see containers are deployed in isolation. So how can they communicate with when different applications are hosted in different containers? Raghavin, so we now as a part of our Kubernetes here we'll be using multiple. Here in Kubernetes we'll be having the concept of master and node as well, right? Here we do have the concept of master and node, and as we continue further in next couple of minutes, we'll see how the entire structure is defined and how it actually works. Clear now? Perfect. Thank you for confirming. Now here we, as you can see here's the market share for the Kubernetes versus Docker Swarm, where Kubernetes is having more than 90% of presence in the market as compared to Docker Swarm, right? Now let's go ahead and understand a simple use case using Pokemon Go, right? So Pokemon Go, as we must be well aware of, is one of the most popular games around the globe to have multi-million, like millions of downloads being done globally, right? So Pokemon Go was a rage, especially in 2016, and it was and it was the most popular game out there at that time, right? Just like we have PUBG nowadays, same way we have Pokemon Go at that time, right? So now let's understand the complete use case of Pokemon Go. What is Pokemon Go and how we can use it? So Pokemon Go, it was a simple augmented reality game where we could simply open up a camera, and again, if there was a Pokemon being visible, then we can go ahead and catch it, right? And this was available for multiple devices, including Android and iOS both, right? And again, Pokemon Go saw more than 500 million plus downloads and 20 plus million daily active users who are actively playing game for on Pokemon Go on a daily basis, right? And that is from different parts of the globe, not from a specific region, but different parts of the globe itself, right? Initially, it was launched only in Australia and New Zealand and North America, but again, it simply inspired more than 5.4 billion users, right, in a single year. All right, and whatever the engineering team had expected, it simply crossed that by 50 times, right? So they were simply expecting this to be downloaded only max to max 1 million times, suppose 10 billion times in the entire lifeline. But since its entire launch, this has got more than what they were expecting. So in Pokemon Go, what we did was simply compiled. Now Pokemon Go is simply built on Java, built on cloud platform offered by Google, right? And then we have Google Bigtable available on top of MapReduce, right? So this is the entire structure of Pokemon Go that it was deployed on. Just a moment. And same way as we can see here we have multiple containers being deployed here, right? So as you can see here we could have deployed only one container, right? But the entire application was built on Java, running on Google Bigtable, and now it was packed with now it was also packed cloud as a cloud data flow offered by Google as a Google Cloud Service. And now this is all deployed. Again, the entire performance here for Pokemon Go was increased by almost 5 times because of the increase in traffic. Again, the same container is again being deployed 5 times, right? And for management of these different containers, the management of these different containers is again done using the container tool, right? And that's why the biggest challenge faced by companies is the application is mostly horizontal scaling, right? So that they can keep the capacity exactly as it is, but again here we can keep the number of the servers, because that's a reality, guys. Because even if when we are talking about the actual deployment in the companies, now let's take two scenarios, guys. Let's talk about two scenarios here. In one scenario here we have 5 servers being deployed. Here we have 5 servers being deployed here, 5 EC2 instances, for example. and each and every of these servers are having 1 GB of RAM and 1 core of CPU, each and every of these 5 instances here, right? And in another setup, what we have here, we have suppose only 2 servers, but again, each and every of these are having a capacity of suppose 4 GB of RAM and 4 cores of CPU, right? So which one of these are, we can say, highly available, or which one here would be more static as compared to the other two? Anyone? Which one here of these can be more stable and can be more reliable? Anyone? Here we have vertical. So what we have done here, we did vertical scaling, and here we had done horizontal scaling here, right? So any guess which of these one will be more reliable, horizontal or vertical? Ronnie, horizontal. Ramesh, horizontal. Perfect for the confirmation. So, Ronnie, Naresh, Surya. Perfect. Thank you for the confirmation, everyone. Okay, Ramesh, so I have a query from Ramesh. So, Ramesh, so is there's a limit for vertical, but horizontal doesn't have any limit? Yes, Ramesh? And here it can be more scalable. For example, suppose for some reason vertical scaling, suppose if this particular instance is non-operational, suppose it breaks down, right? Then the entire load here is on a single server itself, right? Whereas since here we have more number of servers, then we have an equal distribution of the servers. And again, suppose even if one particular instance goes down, then that will not increase the load on the other servers by a greater extent, right? And that's why we go for horizontal scaling as a preferred choice, being more stable as well. Is it clear, Ramesh? Everyone, please give me a quick confirmation, guys. Perfect. Thank you for confirming. Okay, Ramesh. So, what is the role of load balancer here? Okay, Ramesh. For example, suppose here we have one server that we have deployed here, right? So we have only one server, right? So again, we can set a rule here in auto scaling. Suppose if we see currently this server can handle traffic up to 10,000 per day, right? And suppose due to the sales season, suppose Amazon is now receiving 50,000 user per day, right? So depending upon the increased load, what we can do, we can create 2 different servers, and then we can define the division as well. For example, suppose in one server we want to send 70% of traffic should be going to this server, and 30% should be going to this server. The 30% of here of the stake here should be going to this person, right? So then then what we are doing, we are simply distributing traffic here, right? Same way if we have a website, right? In one page we have a blog, we have one page of blog. In another page we have an application, right? Now, blog, suppose anyone, now this is a part of the same website. Now, what we want is suppose who is opening a browser, they should be going to another server. They should be going to another server from another company, right? Or some other server only deployed for blog. So suppose this server is having 1 GB of RAM, 1 core of CPU. And again, if we have an application for the user, for example, if we have the application to upload an image and add some filters to it, right? So here the application sees a big amount of traffic as compared to the blog, right? So what we can do, we can again attach it to another server, right? where we have a storage capacity as low, and it can be adjusted as per the requirement. We can do that. All right, is it clear now? Perfect. Thank you for the confirmation. Ramesh, so it means we can use LB for horizontal scaling. Yes, Ramesh, we can do that. Swati, Feroz, Zahid. All right. So now let's get right back and continue our discussion on Kubernetes. And these are the main challenges faced by Pokemon Go. So the biggest challenge faced by majority of the application is they are not that good with horizontal scaling, right? And but again, for Pokemon Go, the biggest challenge was vertical scaling, and that was a major challenge, right? Because of the real-time activity in gaming environment from different users around the globe. The number was for which was in millions, right? And Niantic, the development company, was prepared for traffic disasters up to 5 times, but again the traffic came to be 50 times more than what they had expected, right? And that's why they needed Kubernetes to make sure that the entire deployment was now the entire company was able to handle 50 times traffic that's coming to the entire application here, right? Now let's understand the entire architecture for Kubernetes first. So Kubernetes mainly has these three main components: master nodes, worker nodes, and distributed key value store, right? Like we have etc, right? So now same like we have Chef, same like we have Puppet, we also maintain a master and worker node, right? So in master, we have the master is connected to multiple work nodes, right? Or worker node, or we can say slave, right? So master node also have the entire same pod, right? And again, same pod. Now, in one particular queue policy here, we can have pod, and then we have kubelet, right? And these are all done using the master and slave architecture. Okay, Ramesh, so LB here, load balancer will be showing the load to all nodes equally, right? We can define that, Ramesh. We can define if we want that load to be shared equally, or we want to have some percentage defined. We can define that. Is it clear now, Ramesh? No problem, as long as you are giving me a good an excellent feedback. Is it clear, Ramesh? Please give me a quick information. Perfect. Thank you for confirming. That was a part of the vertical and okay, but earlier you said fifth node will not load will not go to the other nodes. They had a doubt. So if fifth node is crashed, again, that will simply bring the application down here, Ramesh. If we have not specified what should happen, right? And for that, we do have auto scaling as well, right? So just like we have load balancers, we have auto scaling as well. So we can scale up the resources. We can increase and decrease the number of resources as well, right? As a part of auto scaling, we can do that. Depending upon the logic that we have defined, it will function accordingly. And if there's no logic defined, then the entire application will be completely broken. Is it clear now? Perfect. Thank you for confirmation. So master is basically required for defining the entire cluster, right? So again, here we have multiple entry points for administrative tasks. And again, there'll be only one master for the entire architecture that we had defined here as a part of Kubernetes, right? And Kubernetes uses the ECCD, right, for the interaction here. And then in worker nodes, we have external. Here we can have kube proxy, and then in worker nodes, we have entire runtime defined for workers, and then we have kubelet. We have kubelet here. And after kubelets, we have the worker nodes. So now in worker node, we have multiple container runtime. Then we have kubelets, right? So now in kubelet, we have now. Okay, I have a query from someone. Okay, kubelet here simply means the primary node agent here, guys. When we say kubelet is simply the primary node agent that we are running as a part of Docker. Is it clear now, everyone? Please give me a quick information on kubelets. Okay, Ramesh. Okay, Edureka, guess what is etcd? So etc is simply we can say a key value database store. Now, basically, it is useful for storing all the configuration for the Kubernetes, right? So whatever configuration we have defined for the entire cluster for Kubernetes, which contains multiple Docker, right? Where we have multiple Docker containers. So the configuration of all those Docker containers are stored in ECTD, in EDCD. Is it clear, Edureka guest? Okay, Surya, so etcd is simply, we can say it contains all the configuration defined for the entire cluster, right? So for storing the configuration, now by configuration, we means a simple template, right? So for storing the entire configuration, we can save it as a part of etcd, as a part of Kubernetes. Is it clear now, Surya? Please give me a quick information. kubectl. So yes, kubectl is basically used for making sure the entire and like all the ports that we have defined are well configured or not, right? So we can say it simply make sure that all the nodes are well configured or not based on the etc that we have defined. That's the main job of kubelet. All right. So that's why we had this. So that's why you can see the multiple example for us here. I shrimp here. Now, these are the main challenges faced by Kubernetes in setting up the entire network. Here we do face the challenges of assigning a unique IP. Here we have the communication of containers. Kubernetes also have to take care of the communication. That means if multiple containers has to communicate with each other, then that is done smoothly. And pod-to-pod communication, and if possible, we can also access the internal application externally. So these are main challenges faced by Kubernetes network. And if we have to understand the complete deployment pipeline of Kubernetes, so first of all, what we have is here we know in Kubernetes, we have first of all the entire build server, right? So the build server creates the entire build. Now here using the build server, we can create the entire image for the Docker, right? Because for building images in Docker, let's see how Docker images are built. First of all, here we have now for building the image for any Docker, first of all, here we have a Docker file, right? So we define the entire configuration or dependencies that is required for the application to run in Docker file, right? And here we have the image of the and again, Docker file are used to create the image itself. Docker files. Now through Docker files, what we can do, if we have the application here, if we have the application deployed, so through Docker file, we can define how the image and what should be the image should contain, and what kind of dependencies have to be met in the image, right? So based on the input defined by Docker file, here we create entire image for the container that can be attached to it, right? And then this image is attached to the container, which can be used for deployment now as a part of Docker Hub, right? And then we have now here we can make multiple HTTP callback. And again, once it is deployed here, then each and every container can be passed on to Kubernetes, right? Where you can keep a check of all the containers that is currently being deployed and can maintain a health check and make sure the entire, suppose if you want to change something for the entire containers, then that can also be done easily using Kubernetes, then doing the same thing manually one by one. All right. So that's the setup here for the Kubernetes. So let's go right back. So now if we have to compare this with Swarm, right? So Swarm contains multiple now. In Swarm, suppose let's say we have an instance, right? So here we can connect this instance to some other instance which can be attached to the a bigger, so we can say a cloud, a Docker cloud, right? Whereas in Kubernetes, here we take care of the deployment using load balancer as well. That means based on the load here, the instance load should be distributed among which particular container, right? And then we can go ahead and perform all the scheduling as per the requirement. All right. So are we all clear on the basic setup and structure of Kubernetes till this point? Please give me a quick information, everyone. Are we all clear on the concept and basic deployment and structure for Kubernetes till this point? Surya, Rahman, Rupa, Swaroop, Edureka guest. That's definitely Ramesh, because again, here, Kubernetes is not, again, that's the first pointer that we had discussed on Kubernetes, right? It's a bit confusing. It's a bit complicated as well because installation, again, is highly complicated as compared to Docker Swarm. So now even even in context to timing as well, right? Even in the timing required for installation of Kubernetes, and that is higher as compared to any other, or we can say as higher as compared to Docker Swarm. Okay, so I have a query from Venkat. So what is the significance of pod? So we can say pod is simply connection of multiple containers, Venkat. We can say pod is a collection of multiple containers. Is it clear now, Venkat from YouTube? Please give me a quick confirmation. So when we talk about pod, so pod is simply the collection of multiple containers as a part of our Docker setup. When we create multiple containers, then the collection of those can be termed as pod as well. And spatially in the same host, and spatially in the same host. Okay, Ramesh, so is there any limit? Yes, Ramesh, there is a limit. Now, in Kubernetes, what we can do, we can have at max up to 110 pods per limit. We can have per node now. In terms of number of pods, we do have a limit, and that is 110 nodes per node, not more than that. Is it clear now? Perfect. Thank you for the confirmation, guys. So any more questions that we might have, guys, on Kubernetes? Please go ahead and ask so that we can have a complete clarity on the concept of Kubernetes here. Because Kubernetes, if we want, we can install on both the platforms. If we have our own VM running, then we can download and install a VM like we have Oracle VirtualBox. We can go and install the VM, the Kubernetes on our local VM, or we can use if we are using any cloud platform, like for example, if we're using AWS, then we can set up Kubernetes on AWS as well. We can do that easily. Okay, Rupa, so for which technology we can use it? Any restriction? Like what kind of technology are we referring here, Rupa? Kindly elaborate so that I can answer correctly. No problem, Stuart. I hope you had a good insight on Kubernetes through this session. Stuart Jones from YouTube. No, Rupa, there is no limitation. We can use .NET, we can use Java. There's no limitation there. All right. Yes, Sarup, we'll be sharing the PPTs as long as we are getting the excellent feedback. We'll definitely share that. Okay, I have a query from Bunny. So Cubelet and pod difference, please show Bunny. Let's go ahead and see to this. So a collection of multiple containers. Suppose let's say here we have containers C1, C2, C3, C4, and CO as opposed CN, right? So a collection of multiple containers will be called as a pod, right? So then that collection for multiple containers in here, right? So these entire collection is termed as a pod here, right? And kubectl is simply a service. We can say kubectl, we can say works like a, now for a simple layman understanding, we can say kubectl is simply a service, right? We simply make sure that the entire, suppose the entire cluster is deployed on the same IP, right? And that means suppose here we can plan out so on which particular instance they would be deployed, right? And again, it can make sure that each and every container here are that is a part of the pod. These are running as it should, right? And again, if there are no errors inside any of these containers, that is a part of that's one of the tasks for kubectl. All right. So are we clear on this part, Bunny? Please give me a quick confirmation. Bunny Taddy from YouTube. Perfect. So thank you so much for the confirmation, guys. No problem, Bunny. All right. So let me share the link just a moment. Now, to continue on the journey that we have started today here, guys, so let me share the link for the entire full-fledged training that we have so that we can now if you want to continue our journey that we have started today here, we can simply go ahead and join this, right? So let me share this link with everyone for our certification training on Kubernetes, right? So Kubernetes is, as we know, is one of the main tools that we use as a part of our entire DevOps strategy, right? So in this module here, we'll be focusing on the entire introduction to Kubernetes, the Kubernetes architecture, how we can deploy an app to Kubernetes cluster, how we can manage different states with deployments and expose apps, scale app, and update all the apps in Kubernetes, right? So all of these will be a part of our discussion as a part of this entire certification training along with multiple projects, right? So let me share this link with everyone. Here you go, guys. Yes, Naresh, we do have multiple sessions on Chef and AWS as well. And again, for that, we can be a part of the meetup. so that we can be notified on all the webinars that we are conducting on a monthly basis, on a daily basis, right? We have webinars on different topics that we can take it up, right? And I guess it's almost time now, guys. So let's say we wrap this up for today. And again, thank you so much from the bottom of my heart for joining this entire session. I hope you really had an informative session for the last 90 minutes now. And thank you so much for joining. And once we end the session today, you all will be getting the NPS feedback form. So please do rate us excellent in that feedback form as a small token of appreciation for the hard work and time that we have put in. And so please do rate us excellent, and hope to see you all soon join the entire session so that we can continue the journey that we have started today. Thank you so much for joining, guys. Have a great day ahead. Take care. Bye-bye.